Okay, so with this next panel discussion, there's an obvious common theme here where Parker, Adrian, Hakases, and Griffin and myself have been involved with doing a lot of these different Tesla experiments. Eric Dollard should really be here with us, but hopefully he's maybe at least streaming and enjoyed some of those presentations and demos. Does anybody have any opening statements to?
Yes,
Okay.
Is this working?
Yeah.
Okay, I've been to several ESTC conferences now. I think what stands out particularly this year, because it feels like somehow also the beginning of a new cycle, is that so many of the presentations and the demonstrations seem to have an underlying common theme. So in other words, they have a theme which is related to somehow the natural order of things. So digging deeper down into the principles behind some of the things that we're researching. So if I take my own demonstration, for example, that's working towards revealing the underlying natural order in electricity, and demonstrating that there actually is a natural order. It's organized, and that's the first time I've ever seen that. So, and also finding that theme in some of the water presentations that have been presented here. And I think that is such an important drive moving forward, is really getting down to understanding the fundamental principles. I mean, we had a great conversation with Mark McKay over the motor, and getting down to what is really the principle behind that is actually providing that additional energy that makes it made it such a fantastic motor before it got damaged. So I think the emphasis of working at a deeper level together with all our demonstrations is something that I've seen most strongly in this year's conference. The other thing I'd also like to say is that there's another person here that we haven't acknowledged yet that actually makes it all possible for us to all come together to actually enjoy this conference, talk together and everything. That's you, Aaron. You actually make it possible for us to all come together. Round of applause for Aaron, please.
Thank you.
You're welcome.
Parker, would you like to share maybe some of the things that you got out of coming to this year's conference and what you plan on doing after you get back down to Texas?
So I figured out I can use like some different like techniques to get better results, and I figured out a new easier way of tuning the coils, and I can apply that to my coils and tune them better.
And so you feel you have a good group of people you can tap into and share results and move forward in the way you want, and it's awesome. And you're going to continue to put videos out on the internet, and have you heard whether your TikTok account has come back up yet?
I haven't, but I went ahead and created another TikTok account, which is Dr. Parkenstein 2. So that's what I named it.
He had over 800,000 followers, and the day he showed up here, they took it offline. I hope it really is for what they're saying it is, and it wasn't anything else. But hope that works out, because a lot of people really want to continue to follow that. So check it out. Make sure you follow his TikTok page, and then also AMI Innovations.
Yes, well, that's correct.
.com. Jeremy?
Near-term future, what was the question?
Anything you want.
So, I got a lot out of this. I originally presented talking about the Tesla coil, and I thought the calculator that we made based on Eric Dollard's research was quite accurate, and that we were 90% of the way there of having a perfect working model. After hearing Adrian's presentation, I think we're back down to 50%. But we'll be going back into that, probably refine the model. I'll have to retest all of my coils with the knowledge that I've learned over the weekend, and then working on an improved ground, and then collaborating with both Adrian and Griffin to get some to do some more higher level impossible experiments.
Go ahead, Griffin.
Okay, well, I mean, I would say that there's another maybe a year or so, or possibly within the next coming 6 months, that there's going to be another yet rigorous work episode, just in collaboration with Hawkins and Adrian, in terms of just tiller communication and the refinement of coils, as you said prior, but also just in developing the vacuum even further and possibly even discovering some new aspects in this realm of single water terminal areas and as related to the vacuum. But of course, granted with time, anything's possible, so who knows what other aspects are going to show up.
I'd like to add one more thing
Sure.
if I could. The other thing we also discussed, the three of us, so myself and Griffin and Hakasis, is I proposed the possibility of a telluric experiment that we will attempt to do in the next year on a transatlantic basis. So in other words, I have a generator and receiver system for telluric experiments in the UK, and Griffin and Hakasis also have their system here. So we seem to be in the perfect opportunity.
And now that we know what we're actually doing,
Well, we learn as we go along. We have the opportunity to try probably an experiment that's actually never really been done since Tesla's time. So that's an exciting step for the future. So who knows what we might have to report next year.
And do you want to rephrase or elaborate exactly what that experiment is?
Yes. So one of the most important things that Tesla demonstrated was his Tesla's magnifying transformer. And he proposed and experimented and spent many years looking at the idea of having a transmitter and a receiver separated by vast distance and not connected normally like you would connect these transmitter and receiver with wires, but using the ground as a telluric connection. So telluric means under the earth or associated with the earth, and to actually join those together using the longitudinal mode that we talked about during the conference. And in principle, if that is all tuned properly, he proposed that the longitudinal mode means you could put in the power in the transmitter and you could get all of that power out at the receiver with no loss over a very vast distance. Now that's something quite special. I mean, Eric Dollard has done an enormous amount of work on this, and we're now in the position really to carry on that work. And we don't know if it's possible. We've done some of our own telluric experiments already. If you want to see the telluric work that AM Innovations has done so far, it's all alongside all the other research. It's on my website. You've also seen what has been presented by Griffin as well, where they've got to. So we really are in a position within the next 6 months to actually start doing this.
and it might not work, but it might. And if it doesn't work, we'll learn a lot in the process.
That's the
And-
joy of the research and
Yeah.
the journey.
Yes.
Yeah.
As far as long-distance type of experiments, one thing that stuck out to me when I learned about Parker's work when I was contacted by Nick, and if you heard Parker's presentation, well, people are getting down and kind of gloomy and stuff, so what about start a pandemic of happiness and love? So he built the magnifying transmitter to transmit on at least a harmonic of 528 hertz. And so Nick had wound a coil, saw the LED blink. I'd like to get more of that verified, but being down in the DFW area, some of these other circuits are a little bit more advanced, but I think even people who are do not have much experience or background in the math and the engineering and all this, the coil that you showed about like a basic receiver coil for 528 to be able to receive like an LED, I think people maybe around down in the south and stuff should start replicating these coils for 528, plug it into a good ground system, have some Zoom call where Parker is turning on his big Frankenstein switch and scaring the neighbors and seeing if their lights are blinking from hundreds of miles away. Because that's an important, that's actually very important to do because it also validates it more with the more people who are getting the same result. And I think something like that is something that could kind of go viral, you know, because for one, it's unbelievable. We know the principles involved in how it's done, but to see, you know, a lot of the youth replicating these coils and doing that, I think that would be something pretty special, you know. Any comments, any online questions or anything relating to any of the Tesla stuff, or how about any of you down here in the audience?
And I guess one thing before we move on, in the course of this experimentation, that I think We just have to get down to the fact of whether or not this is Skywave or this is truly Tesla's mode.
Mhm.
So I think that no matter who it is, no matter who wants to replicate it, that's the real answer. Because if, of course, it is Skywave, then the whole thing goes out the window. But if we do it correctly and do manage to show this is the Tesla wave, then we truly have something there.
Yes, I agree. It's good.
We had one question online. Can you recommend a good vacuum pump?
So I would say it depends on what their application is. Now, if they're working in the ultra-high vacuum range that I'm working in, then I would either recommend either a diffusion pump made by the Edwards company or the Varian company, which is based in England. I would also recommend either a turbomolecular pump for its simplicity and just its very small size. Pfeiffer, a German company, usually creates them. I have a Pfeiffer. It's proven to be quite successful, quite reliable. But of course, a roughing pump for lower vacuum and just for these type of pumps, I would recommend essentially any Edwards vacuum pump, as they are also based in England, but they are of rigid construction and are fair lasting.
And if I remember correctly, two-stage vacuum pump, and I think 6 feet per minute or more. It's been a long time since I've researched.
Yes.
Question?
Yeah, I for one would like to join this global Telluric network. So first thing I'm doing when I get back home is digging a hole down under there. So what happens when you start doing these things and you get interested parties involved and you want to be able to explain things? I would have to say one thing I still don't know how to explain is what is a longitudinal wave. Can you offer perhaps some more clarity on that?
I'd like to give a resource to definitely watch. On ericpdollard.com, there's a free videos link, and on there is an old Borderlands video, 2 of them, about the comparison between longitudinal and transverse waves. I can't remember the exact title, but that's one of the free videos embedded on that page. ericpdollard.com, free videos. What's the title?
I think it's transverse versus longitudinal waves. It's about 50, 60 minutes.
That'll be easy to find, yeah.
And there was one more.
There's one on, had the extraluminal title in it, but it's just,
Extraluminal communication.
yeah, it's the one where he's demonstrating a benchtop model with a analog computer network,
Mhm.
and that's, yeah.
Old Borderlands videos.
If you would like to get the simple analogy to start with, I mean, and it comes out, I mean, it is done in those videos. I mean, if 2 people hold a piece of string and they hold it together, and you whip it like that, you're going to see a wave passing down the string. So that is like transverse electromagnetism.
And the
Now-
amplitude shrinks over distance.
Well,
That's correct.
that I get.
The
So-
amplitude shrinks over distance. So if 2 people now then also hold a broomstick, and if I push it, the moment I push it, you experience it. And if you push it back, I experience it back the other way. So that is the analogy of the longitudinal magnetodielectric mode. So
And it's instantaneous. No loss,
Yes.
90 degrees to the direction
Right,
that it's
so
moving.
let's put it in the context that I most anticipate it. I work at a university. I'm trying to imagine and explain it to a physics professor or
Yep.
something like that.
Yep.
I can imagine a bit of eye rolling going on if I make
I should imagine.
one trip, right? So, I mean, what is the medium? It is the dielectric only in this case?
I might actually so some of that would be longitudinal wave. In my supposition is that the field is largely traveling through the dielectric rather than the conductor. So essentially it would be, how do you transfer energy across space? There's 2 ways to do it. You can either use a wire, which is a conductor that travels magnetically, or you could use plates of a capacitor that transfers through the dielectric medium. And they both have loss, but the dielectric tends to have a lower loss, especially at great distance.
Would not a similar effect happen in the magnetic field alone? You're talking electric field alone? Would not a similar thing happen in magnetic?
You always have to take the 2. So if you go back to the beginning of what Eric Dollard formulated, the quantity of electrification requires the dielectric induction field and the magnetic induction field. And all of the properties and phenomena, transmission or discharges or longitudinal effects, they all come from the relationship between those 2 induction fields. So for greater or lesser degrees, sometimes the dielectric induction field is greater, the magnetic induction field is less. So then, for example, you might expect to see properties relating to things like charging at a distance, dielectric effects. I mean, for example, and then if it goes the other way, before I go there, you might have an emphasis, for example, of the magnetic induction field. So it's always the relationship between the two. And if you look at the longitudinal mode, you still have is the longitudinal magnetodielectric. So they are still both together, but the relationship between them is different. So in the longitudinal mode, you have essentially the dielectric induction field and magnetic induction field are coherent in space, but not in time. In the transverse electromagnetic mode, it is coherent in time, but not in space.
Is that, so that would be also, you would swap them around when you're dealing with magnetic versus electrostatic?
Flip the equations.
Mhm.
Yeah, or the concept, I guess, yeah. Does that not then point to what we're seeing here? We've got magnetic devices and we've got electrostatic. Does that mean they might too be using the longitudinal principle there?
Very much
And
so.
just role reversed?
There does seem to be a lot of common
Very much
factors
so.
between a lot of the credible devices.
Yeah.
Seems to be a pattern here, yeah.
Exactly.
Yeah.
Okay, thank you.
That was what I was also referring to in terms of the commonality of
Yeah.
the underlying order. The same principles in the underlying order of life seem to be coming out in so many of these demonstrations.
And so they should, because they're not separate.
Absolutely. It is only, after all, the one life.
Yeah. Also, one of my stated goals that I wanted to achieve in my first, visit here was what's the commonality? And I think I'm lucky to be here. Actually, I think I'm seeing something here at least, beginnings. Yeah.
Fantastic.
Okay.
If they are all valid, there's probably one or two common factors that drive all of them.
It must be.
Yes, the underlying principles. I mean, if we were to extend it even further and go even a step further than that, if there is a natural order in what we see, and I believe from the demonstration, say, take my own demonstration, that it is showing a natural order, it is showing an underlying fractal Fermi discharge, which we know that the fractals appear all over the place in life. If we go a stage further and I look at the results there where we also have sequences of those discharges that lead from one to the other and repeat, then we might even conjecture that there's, in the inner electricity, there is the possibility of intelligence.
I'm thinking Fibonacci there as well.
Indeed.
Yeah.
Indeed. So these are conjectures and questions which could lead us into a much deeper understanding of in this case, electricity, but ultimately in the natural order of how things go together.
Yeah, because that's the other thing I'm finding unified here is I'm, a bit of a mechanical man, so I see everything in those terms, but there's all the guys under health, etc. here, and they're talking the same thing as well.
Yes, absolutely.
So not to be forgotten, of course. All right, thank you.
Thank you.
Go ahead.
Yeah, we have a question online. We've seen Tesla coils, wireless lighting, and Tesla turbines. Are there any of his other inventions you're waiting to try?
The lighting brush effects? Aren't you
Yes,
working on
I
those?
think that one of the main effects right now, which is slightly overlooked or slightly misrepresented, is the very brush effect, which he considered and firsthand observed. So this brush effect, for those who do not know of it, is simply a rotating plasma beam, so to speak, which occurs in a vacuated sphere devoid of any metallic electrodes. And this beam seems to contort itself over a duration of time regarding to how much time it is worked or handled or impressed by an RF source. Now, it doesn't seem to the date that anybody has been able to successfully replicate it in the actual brush bulb itself. Now, there have been some other rotating effects and other interesting phenomena which do present themselves in these evacuated terminal bulbs or various brush bulbs themselves, but none of them are actually in relation to the exact brush formation which Tesla observed. And for that, I believe that it must be the mixture of whatever the equipment in which these bulbs came off of, which are incorporating themselves into this very brush formation. Now, this is, of course, one of the lines of research which I'm trying to adventure upon, because what he states is that the very sensitivity of this brush is quite so that even at a distance, the slightest magnetic field or any electrostatic impression upon this beam is able to rotate it or affect it at a great considerable distance. And of course, with that being in mind, we could see that there is a practical application to this. For that, we do not know just yet, until it is, of course, successfully replicated.
I would say also, in answer to that question, that it would be good to have more research into things like radiant energy. I know we talk about it a lot, but the radiant energy, sometimes called cold electricity, those kinds of things, I mean, for example, we're talking with Mark McKay about the grey motor. I mean, to try and find the underlying principle of that motor, it appears that, you know, we went back to the point of the popping coil. I mean, really, that's just a rotating popping coil. So if we understand the principle of the popping coil, of how the load can be lifted so far, and then we go back to, well, what's special about the popping coil? And behind that is the electrostatic generator. And what it turns out is that Gray, from what Mark shared when we were talking about it, is that Gray got that electrostatic generator box from a lab technician that worked with Tesla. So in actual fact, the essence of it came directly from Tesla. And the people in between, they used that principle, but they didn't understand the principle. If we understood that principle clearly and properly, we could make that motor run again easily. That's just engineering. I know it's just engineering, but if we don't understand the principle, we can't make the motor work. And so I would like to see really much more research and experimentation into really understanding Tesla's radiant energy. I mean, the underlying principles, even under the induction fields. So even under that layer, it's all in the natural order of how things go together. These are life's natural principles and processes.
And
So-
not something complicated either.
No, indeed.
So we're not talking about building a gray motor that has multiple phases, 12 different coils, multi-kilovolt, whatever. The popping coil is the simplest embodiment, which was, 2 separate coils and maybe either copper or iron wire. We know there were certain voltages involved. It's, I'll say, rather than trying to reconstruct a modern jet engine from a photo, we should go back and try to understand the principles that we're operating at. So instead of, a lot of people try to go straight for the brass ring, but instead of building a complete working aircraft, you should, build a Model T first,
Well, and at least understand how the principle
Do
of how
the
the
Wright
aircraft
brothers
flies.
flight. Do the Wright brothers flight before you build an SR-71.
You really need to understand the principles
Exactly.
of flight
And if you
before
don't,
you build
if
an
you
airplane.
don't and you succeed, then it would either be blind luck or even worse. You have something that succeeds for a day or a week, and then you come back later and it doesn't work, and you don't know why. And
Yeah.
because you didn't understand the principle, so you'll go mad the rest of your life trying to figure out what went wrong. I think you might know Hutchison and his great endeavor.
Yeah, I agree.
Today is, what month is this? July? This is July 10th. Did I mention that earlier?
You
Today
stole
is,
my
Today is
thunder.
Nikola Tesla's birthday. Give a little Tesla bobblehead going on there. You have any comments?
Not really, no.
We've got a couple more
Go for
questions
it.
online. To tune a single coil for LMB, should the parallel and series resonance be tuned, I'm assuming, to the same frequency?
Well, that's a good question.
It is a good question.
Actually, you can't tune them to the same frequency.
So-
In an LMD mode, the series and parallel modes are distinctly there, and you can select which one you tune the generator to. So if you tune the generator to the series mode, you are going to emphasize the transverse electromagnetic mode. But if you tune to the parallel mode, it seems, it's not fully confirmed, but it seems that it's more suited to the LMD mode in the cavity. That's what we're.
So more specifically, when we do all the tuning and we're doing the field meters and lighting bulbs, we're using the series mode. We're using the conventional quarter wave resonance. The parallel mode that Adrian talks about, we've done just some very brief tests with the vector network analyzer, but it seems it's about 9 to 15% higher in frequency compared to the series mode.
And the
And
only-
and it does seem to vary depending on the coil and a lot of other factors, but it's about 10% over that frequency. I don't think, I guess you can't match them, but we are starting to notice that the higher quality coils tend to have a longitudinal mode that's closer to the series mode. So
Yeah.
they're closer and closer, and the closer they get, the Q factor or the magnification factor starts to go up.
And the determination of this mode isn't necessarily readily available or that easy, as typically the impedance associated with this curve is quite high. So it is almost impossible to measure the longitudinal mode with a typical signal generator and a field strength meter.
Gotcha.
Therefore, it is best to use some type of vector network analysis,
Unfortunately.
which seems to be the only working method so far, which is able to determine quite accurately with great precision the actual longitudinal mode and just where it rests on the
Yeah,
spectrum.
on a VNA
I
it
would
shows
just
up.
add to that, Griffin.
Yes.
I mean, I agree that is the ultimate way of doing it. I would just add that it is possible to see the parallel mode with a signal generator, but you need to put a matching unit in between.
Oh, yes.
So if you have a matching unit in between, then you can see the parallel mode. The problem with the parallel mode, in a sense, in measurement, is that because its impedance is so high, when you
Like
put a
50 to
signal
100
generator,
kilo ohm.
when you put a signal generator and tune that way, basically the low impedance of the signal generator just squashes the parallel mode, and you don't even see it. And that was what amazed me, because when years and years ago, when I used to use vector network analyzers in things like microwave and submillimeter research that I was doing. And I had one at home, and then one day I just thought, I wonder what a Tesla coil looks like. And I mean, I knew about the series mode, but when I measured it, I realized, wow, this has got a parallel mode too, and it's not so far away, a series and a parallel mode. And then I started exploring more, single coil, 2 coil, 3 coil systems, and I realized that they were all interactive. And where you tune and how you tune and how you couple the coils, whether they're direct coupled or whether they're magnetically coupled through K, the coupling coefficient, it determines how you emphasize that coil system. So you know, how the cavity works, how a longitudinal cavity is selected. So when you want to do, for example, telluric transmission of electric power, how you set that coil up in relation to the transmitter and receiver is very important, because you are selecting where the cavity is, how the transformation goes between the transverse mode and the longitudinal mode, and then back across the cavity, and then back from the longitudinal mode back to the transverse mode in the receiver. So understanding how the series and parallel modes work, when you're emphasizing the dielectric induction field and the magnetic induction field, and when you are emphasizing the transverse mode or the longitudinal mode. So it is a dynamic set of things that you need to explore. And that is what we are essentially, the vector network analysis helps a great deal to understand the coils.
And admittedly, when you start out, you know, vector network analyzer is not basic. That's, you know, way up there. So you do have to do a lot of experimentation and sit around on the bench and wind a few coils and play around and till you get comfortable. You start to understand the processes that are going on. And then once you get comfortable understanding things like impedance and Q factor, you know, all the stuff like that, then it gives you a foundation that you can finally start, you know, pick up a VNA and then follow Adrian's videos and such to try to understand what the coil's doing. And that's even with one coil.
I bought a VNA right after the 2019 conference when Eric
Same.
did the 20-to-1 scale model replica. I got the exact VNA, took it home, and I was so excited, and I was calibrating it. And after about 45 minutes, I put it back in that cardboard box, and it sat there until it's still sitting there.
My experience is almost exactly the same until.
So I'm thinking,
until
all right, when Adrian
this
gets
morning.
back here, we're going to get that thing rolling. But I'm glad he did the presentation so that hopefully Mark and Paul, at least being in Spokane, can help me understand and interpret what's going on, because we're going to be
Absolutely.
super tuning everything we're doing. You know, Eric kept telling me, you know, with the MWO, if we can tune that doorknob cap on that pulse cap board inside that pulse modulator for the third harmonic, we're going to take the output to the next level. He thinks we actually almost got fairly close just because of the kind of performance we're doing with the size of the rating of the transformer in there. So that's pretty good, but we want to, you know, get it on as close as possible.
You can do it. You can do it with all the coil systems. I mean, the technique of first of all bringing the coil system to balance with whatever it's a 1, 2, 3 coil. I mean, telluric, it could be 6 coils involved, both at the transmitter and receiver. You bring the whole system to balance, and then you emphasize or pick the modes that you want to use according to the application. But until you actually really balance the whole coil system together in the frequency domain, then it's hit and miss. You picking this resonance or that resonance without necessarily properly putting it all together for the purpose that you intend to. So for example, I mean, a coil system designed to explore Tesla's radiant energy and matter is going to be set up differently to a coil system that's designed for telluric transmission of power. If you want to do the kind of natural order type experiments I'm doing, like the fractal phone and things like that, it also requires a different kind of setup. I mean, each of those boxes, so the coil itself, the generator, and the power supply all have specific properties that are picked to actually reveal that kind of plasma discharge phenomena. And with the vector network analysis, you can set all of that up. It'll be exactly the same with the MWO.
I would like to mention that Eric taught us how to measure series and parallel with a little current transformer, similar to kind of what the little ferrite rings are on the cosmic induction generator coils.
That's the matching element.
Yeah.
You can do it with the matching
Yeah,
element.
with the one of the cables going through it, and we have a little Simpson analog meter and signal generator, putting it in, looking at where you got the peaks, you got the dips, depending on what you're measuring. You got to short the pulse cap board in the right place, depending on what you're measuring. So you can do it that way, and I would probably recommend to learn that old school simple method, because
Absolutely.
We'll have to find that.
because it's a very there should actually be a presentation on that. I think I actually did how to measure resonant frequency with that particular concept at one of the conferences. It's a little $3 video on eMedia Press, but that should really be done with a good whiteboard presentation and everything. So it's
Yes.
kind of like kneeling down on a stage
yeah.
and bad lighting and stuff. But everybody should learn how to do that, because if you have an analog voltmeter, little ferrite ring with some windings on it, then you can actually do that.
I'll have to try that.
But this takes it to the whole nother level, the VNA.
Well, it's critically important to do what you're saying, because that, to understand the basis and the basics of how to doing it, in doing those experiments with a matching transformer and everything, then you are acquiring the necessary background skill and knowledge to actually work with this system.
But it gave me the
as
feeling
simple
of
as
what's going on too.
Exactly, with
Yeah,
the experience.
yeah, it
of
gave me the feeling, the
Yep.
intuitive.
Yep.
I was able to grok what was going on.
Yeah.
But, start simple. Start with even, a battery and an LED. Start one from the smallest building block and then build out and expand your vocabulary. Because, we've spent more than 6 months just winding one coil and playing around with one coil. No primary, no secondary. And I guess you could call us experts, and we're still, that's how long it's taking to figure out how these work.
It's not necessarily like you could understand just the complexity or the dynamic relationships of a coil, just
So
a
don't
single
feel bad
coil
if
overnight.
don't feel bad if you don't get something in a weekend.
Well, let me give you if you want to talk about experts, let me give you the experience of, we can use the VNA, but my experience, for example, with Eric Dollard, with the 20-to-1 Colorado Springs, we did the VNA measurements on that, and you know what? The whole thing was goddamn balanced completely right from the beginning. I mean,
He knows what he's doing.
He had actually balanced, I mean, obviously, Tesla did the original, Eric did the translation to the 20-to-1 Colorado Springs, but when you've got as much experience as Eric, I mean, he can just tune it. It's the feeling. You can tune it through the feeling of it. And when we measured that thing, all 6 coils were actually pretty damn close, right on the balance point for what was needed. So that's 50 years of experience. And in that regard, actually, Eric didn't need the network analyzer. I just confirmed it. I was interested to see how it looked. And it was stunning. Stunning piece of work. Eric is, for us mortals, we need to use the vector network analyzer.
Same as Tesla. Well, and Tesla's-
But you had one for a while?
A
The
few years,
exact-
just
the
after the
exact one?
2019, the same thing.
And
But
you keep looking?
but it's
No.
reading the tea leaves. You don't know how to use it. It's
Seems
magic.
intimidating at first.
there's 40 different options on that, and even knowing, which chart to look at. And then from there, you see a chart, and then what does the chart mean?
I think
That's-
it's the options that are proposed or it allows, because there are many imaginary components which you could select, but for this case, they're not needed, although it could be quite intimidating to the first sight of it.
I mean, I'm really hoping we're going to see Eric back because, I mean, what you can learn from Eric, just being with him working alongside with him, the amount that I learned working alongside Eric on the 2019 Colorado Springs was phenomenal.
And also a lot of the stuff he has is online too. You can watch a lot of the lectures, a lot of the videos. History and theory of electricity is probably one of the best primers for even a non-electrical engineer to understand the history of electricity from its formation up into Einstein.
And I think those are all on my YouTube channel, youtube.com/Aaron Murakami. And if you type in Eric Dollard in all my videos, there's a whole lot of them. But there's some of these old ones, history, theory of
And you might have to watch
electricity,
it like 5 or 10 or 15 times before you start understanding what they're talking about.
And they're
I
4
mean-
hours long each.
Well, if you're on a 14-hour flight,
And then you just recently purchased a VNA, and you're going to be learning to use it. So he'll, of course, have 10 videos out there on his experience with it before I even measured my first coil, I'm sure. Question, Wayne?
Yeah, I'm wondering if you have a caloric system using longitudinal waves, can you pass data across that? I'm thinking telluric internet backbone, perhaps?
Well, so what it seems to be for now, at least the two other colleagues which I'm slightly in touch with, Stephen McGreevy and Steve Young, that both of them have confirmed that even in the case where it's primarily longitudinal, except that there is a transverse electromagnetic component, there seems to be a certain boundary that only impulse electricity and continuous wave operation seems to dominate, as any form, even such as amplitude modulation, single sideband, what have you. That does not seem to pass very well, but then again, their balance could be slightly off tune. But from the signal strength measurements on the received side, it seems as though continuous wave operation is the best, so telegraphy is probably the best
minimum.
way. But of course, telegraphy could be adapted so that certain modes and forms of telecommunications in the form of data or encryption could be possible, but this, of course, is highly speculative and just hypothetical.
I really don't feel it's going to lead to the kind of data transmission that we see with the transverse mode. So I mean, if you look at
you're not
how
going to get
much
5G through the earth.
Exactly.
if you look at how much data we transmit and we pass through as Hackerson says, 5G, telecommunications, those kinds of things. That is not the frequencies that the carriers have to be so high frequency in order to get that amount of data onto it. That is not really realistic at all. I mean, if you think that we are doing experiments in the 160 meter amateur band, which is, say typically at 1.86 megacycles. Now, sure, there's a certain amount of data that you can put on that, but I mean, we're using that because it's convenient at the moment. But really, if you're going, probably you will have to go down to much lower frequencies. I mean, Tesla was working around about 45 kilocycles. And it might be more than likely an answer that from our experiments that we're going to have to go down much lower in frequency to get something like the transatlantic experiment to work. So the amount of data that, for example, you can get onto a 45 kilocycle carrier is just, it's not at all, it's just almost Morse code. I mean, it's just going to be on and off and on and off. I mean, what it might be useful for, and Griffin, maybe you know more about this, is say, underwater communications, say, for a submarine.
Yes, so submarines typically use telemetry, which is a form of encoded continuous wave, so to speak. And typically, they will operate, well, the Navy operates on 18 kilocycles. There's one on 24 kilocycles. And aviation also uses them up in the 100 to 200 kilocycle band. But of course, it still is efficient to some extent, but the only reason why they use those frequencies is because they are using the TEM, or the Hertzian mode, which doesn't necessarily like to penetrate deep depths through water, which submarines obviously have to use. So of course, that's why they have to use those frequencies. But nonetheless, if we were to, say, employ telemetry for fast data communication at, say, the 160 meter band, I don't see any reason why it wouldn't work. It's a fairly narrow bandwidth, and after all these setups, typically do not operate on broadband spectrum, such as a typical antenna or, say, the Alexanderson antenna system, which in that case, that's getting to a new realm, but that's in a perfected sense a telluric form of communication, but it could also be a receiver for broadband spectrum. But in this case, when we're using 3 coil setups, that's primarily a fixed frequency.
I think that one of the big benefits would be with communication like that is not so much practical day-to-day use, but because it blows away the existing model.
More for a research
It
and
is
development.
impossible,
Yeah, I would
essentially, to
add
do
to- I would add to
longitudinal
that,
transmission
actually.
through the Earth.
Yeah.
It doesn't matter what the bandwidth is or what we get through. It's impossible.
Might
It's
as well,
really, oh, no, go on, sorry.
I was just gonna say, might as well mention the Crystal Radio Initiative, you know,
Yes.
for, especially for beginners or anybody really. So X amount of years ago, Eric proposed the Crystal Radio Initiative. He was at my house and did a whiteboard presentation kind of on the fly about a Tesla-style crystal radio that you would plug into a ground system and see how much power you can pull from your local AM radio station. Who's going to be the first to light a 100-watt bulb? I mean, you might need a ridiculously, you might need $1 million worth of copper in that ground to do something like
I
The
that.
can
coil
assure you-
calculator is
Yes.
exactly made for
I
that.
can assure you it's quite difficult. I've done those experiments myself. I went 300 meters from a 150 kilowatt AM broadcast station. I put a reasonable earth into the ground and used a Tesla transformer. I was able to light an LED. So it's not straightforward. I mean the principles of being able to work and to really make it work, it is still really the principles. We are still, in a way, rediscovering the underlying principles. And I think really, if you look at the telluric side, it really is a research. I see them as a research project to help us to understand the underlying principles that are going on here, particularly for the longitudinal, the balance between the longitudinal and transverse, what works. But in terms of application, I don't really feel that there is a realistic and practical application for telluric transference of power or communications, given where we are currently at. I know that Eric, he said in the past that transferring power through the Earth tellurically, would be crazy. I mean, it was different in Tesla's day when you only had a certain amount of electrical power that was needed. But if you were to try to pass the amount of power, or even a proportion of the power that we currently use on the national grid, or so, you end up heating up the core of the Earth. We could be in a 2012 type situation. It's not really practical, I don't think, in the modern age.
Energy and bandwidth gluttonry, as Eric likes to say.
Yeah, indeed.
But on emediapress.com, search for Crystal Radio Initiative, and there's a video presentation and a book with all the notes and everything, and that is a good introduction for a beginner on
Yeah.
It's a good challenge.
any of this kind of stuff.
And the interesting part is that from those equations which he presented in the Crystal Radio Initiative, by building a coil, there is an error factor associated with those formulas, but that is where
Well,
Bacchus and I have
the
been
online
able to-
calculator was
Yes.
based on the Crystal Radio Initiative formulas.
Except it's a more perfected form because it leaves out the error factor to a certain degree. So there does seem to be a more, how should I say? Do you want to go about this?
Well, let me mention something first.
By all means.
When Haka says, approached me and said, hey, if you need an extra presenter, I could present on how to build a Tesla coil. So I'm asking, well, there's been a few presentations that kind of covered that over the years, and I'm thinking, what's going to make this any different? And he told me it's a little bit kind of more
It's
refined.
going to build it the way
and
Tesla built them.
whatever, and I talked to Eric about it, and I said, is it going to be any different? What's the deal? And he kind of relayed to me what he's probably going to mention right now, but it is distinctly different, and it's an important
Consider that
presentation.
high praise.
Oh yeah, you're lucky. And so go ahead.
And gloating a little bit, I guess, too, because the calculator that Eric made when we started winding and characterizing coils based on his math and his formulas was good, but we were off by average of about 15%. So you wind a coil to 2 megahertz, and it would be off by, 10, what was it, about 15% on average, depending on, a lot of factors. And by the various formulations, by his help here, we did manage to bring it down to, it's like 1 to 5%. So we did
Error
improve on him,
factor.
so it's, glowed a little bit.
Therefore, we could determine mathematically
And
that
it's all online, so you don't have to
certain-
go through
yeah.
the math or anything like that.
Exactly.
You plug in the frequency, the height, the width, your wire diameter,
Yep.
and boom, you're done.
It's simplistic.
Yep. Parker, I have a personal comment for you where I found your presentation very,
Microphone?
very personally inspiring. Because what I saw you doing is with a seemingly quick exposure, then you do a quick dive into something, and then you come up with a project. You built something with that. And that's what's very inspiring to me, because I've been in kind of a mode where I've been flooding myself with information, but I haven't built anything noticeable with that. And so that was a very personal inspiration for me to just jump in with what I do know and then do what I can do and then see what happens. So thank you.
So what project would he recommend you start with?
I would say, I guess you could build like a small Tesla coil. That would be a good beginning
You would
project.
learn a lot
Mhm.
just from doing that, too.
Tune to 528. Any
All right.
online?
Yeah, we have a number of questions online. Let's see, what is displacement current, and do you think it could be a key to really understanding the fundamental electrical process?
Well, we have to distinguish between those two things.
Yes.
There is Maxwell's displacement current, and there is also what we call displacement. I referred to those two things in my presentation, and they shouldn't be confused with each other. Displacement is the is right down. It is a conjecture of what happens right down at the underlying order. So, in other words, it's even pre the induction fields. So, in other words, it's the undifferentiated situation where the magnetic induction field and the dielectric induction field are undifferentiated, and that means that they can basically act and move as one. So they are in the situation where it is coherent in space and coherent in time. And for me, that is actually the real source of things like Tesla's radiant energy, is that in a nonlinear event, when you strike a nonlinear event in a balanced Tesla system, using a nonlinear generator or an impulse generator or something like that, you are creating a transient imbalance in that system. And since the natural order always looks to rebalance any system, displacement, you see displacement. Displacement has to act. So when displacement acts to rebalance these induction fields that can't be rebalanced any other way, then the result of that basically the secondary impulse of that is essentially radiant energy is ejected from the circuit. So the dielectric induction field propagates outwards as a radiant energy event. And that's displacement. I mean, this is all in research. I am making quite a large conjecture in terms of how all of this works, but we are working towards understanding displacement as a difference of transference. Transference is sending something from here to there, like broadcast radio or something like that. It takes time, it diminishes, it has losses. That is transference. But displacement is something completely different. It is a fully coherent phenomenon. It's like the underlying nature, or I consider it to be the underlying nature of not only electricity, but at a fundamental inclusive order
right.
underneath.
All right, we have about 12 questions that are in the queue, so
Okay, so
we'll try to get
brief.
through them. All right, so the next one, would an iron wire coil with high inductance cause high potential when placed in a system with a low inductance copper coil? And do any of you have an opinion on how the Tesla Oh, wait, sorry.
start
there
with the
was a
easy
second
ones,
one.
huh?
Yeah, let's do that one first. All right, stop there.
Definitely you, I think.
I think you have to say it one more time.
Would an iron wire coil with high inductance cause high potential when placed in a system with a low inductance copper coil?
If the low inductance copper coil was providing a magnetic bias and partially saturating the iron core, then by pulsing the iron core, you would decrease the inductance, which would create a flyback function because the magnetic flux that's locked inside the coil would be forced to be ejected. The iron core would disappear, and the flux has to go somewhere, so it would create something like an EMP. I don't know if that's an answer to the question,
No,
but
I would also add, but that is actually also as I understand it, the implementation of the popping coil that was expressed by Mark McKay when he was here. That is the structure of how that's built. It is not the essence of what powers it. What powers it appears to be basically what is called cold electricity. But the implementation of that iron core and that copper core in that relationship it appears to be the popping coil.
Through the process of parametric magnetic variation.
Yes, absolutely.
And then the follow-on, or vice versa, a negative current from an absorbing iron coil to a free-flowing copper coil.
Well, I mean, if you look at what you're doing there, actually, you are in a way you are saturating the magnetic induction field. So in saturating the core with the magnetic induction field, you are in a way emphasizing the dielectric induction field. So, quite possibly so. That might actually be part of the generation of actually cold electricity. It's a good question, actually.
Next.
I think
just
we need a
on that, what
lecture
do you
to
think,
answer
Griffin?
that, unfortunately, so
What
let's
do you
I
go
think
on.
that's quite covered well.
Yeah, okay.
All right. Do any of you have an opinion on how the Tesla ether pump patent worked?
Is anybody
Gosh.
very familiar with that?
I'm not particularly familiar with that either.
Is there
Seems-
another name
Only
for
so many
that?
hours in the day.
Yeah, that might seem like a cobbed-together name for it.
Yes, I'm not
Possibly.
familiar with that. Can it be? Can the question be clarified?
We will see. Let's see. Dun, dun, dun. So this is a question for Paul, or for Aaron, and possibly Paul, except he's not here. Where are we today in developing the Holy Grail solid-state over unity electricity? Is the old Bedini FEG system worth pursuing?
FEG?
It says FEG. Maybe it's MEG is what they meant.
I don't really want to answer that, but do you want to
We can move to the next
talk
question.
about Tom Bearden's MEG, magnetic
It says
energy
Bedini
generator?
FEG system. Is that worth pursuing? So, all right, we'll move on. How do your Tesla magnifying transformers differ from the MWO?
Well, I would say that the MWO is slightly of a more balanced configuration. Now, with that,
If using the
yes.
oscillation
Well,
transformer.
the oscillation transformer, in essence, without getting in too great of a detail of its very construction, it's simply a secondary coil or a high-tension apparatus which is connected to a primary coil. Now, this primary coil, through the course of its middle section, is grounded so that both ends of the secondary create, and with aid of the primary and the disruptive discharge unit connected to it, create more of a balanced tension, whereby the phase is somewhat canceled at the grounded end of the primary in its center, and by its series connection to that of a high potential transformer or single Tesla coil, so to speak of, we're creating in a way a mirror image of a magnifying transmitter, but in such a more balanced way.
All right, next question. Actually, we have a comment from RS, whoever that is. I am in the Dallas-Fort Worth area. I can make coils.
Hey, RS.
Cool.
Let's see. So
He's saying he can make
he can make coils.
coils. He should make one for 528 too. He's probably within a half an hour from Parker. Really?
All right, so question, does the Tesla extra coil, when tuned properly to the impulsed primary coil, work as an earth ground pump?
It works actually as a longitudinal cavity. So the point of a multi-coil Tesla transformer is essentially how you set up the longitudinal cavity. That is, if you think of a Tesla transformer as basically you are transforming, in an ideal case, you want to transform from the transverse mode to the longitudinal. And the longitudinal obviously sets up a standing wave. It requires that in order to form across the length of the cavity. So just in the coil, I mean, the cavity just extends over the coil. But what you want to do is you want to extend that further. So if you take two coils, like these two bottles, and if you properly arrange those with the extra coil, then you can extend the longitudinal mode across the cavity. So the cavity extends all the way from the top bit, all the way through, and all the way up to the other. So in effect, you've set up a standing wave. Energy is passing backwards and forwards across this, and you've set up a standing wave where in the fundamental mode, you're going to have a null point in the middle. And one of the clear ways to measure you've got the longitudinal mode is because it's coherent in space but not in time, is you get a phase change across there. The voltage and current are not phased and not constant over the cavity as would be in the transverse mode. So the extra coil, however many coils you have, you can use a one coil system, a two coil, three coil, but as you connect them and couple them, so you know you get different modes, series, parallel modes. They push on each other. So selecting which ones you're going to emphasize and which ones you're going to use. I mean, Griffin and I and Hakasis were talking just the other day about the best configuration for a telluric, because transmission, or one of the things that I've found with a telluric is that longitudinal mode, you can push it a certain distance into the ground, but if your receiver happens to be too far away, then the longitudinal modes don't add up. They just kind of are cancelled out, disappear in the middle. So there was this idea that we had that not only would it push from the transmitter, but you pull it from the receiver too. Now, to pull it from the receiver is a different arrangement of the cavity with the extra coil than what you've set up in your transmitter. So transmitter, you might emphasize the cavity with a secondary coil to pump as much power down into the earth. And in the receiver, at the other end, you're emphasizing the cavity with the extra coil in order to help to pull that longitudinal mode and get them to join up. So, I mean, again, these are conjectures that we're making, things that we're exploring and experimenting. But that's you know, when you just talk about the extra coil, it can't just be just an extra coil added to a Tesla coil. You have to look at the whole dynamics of all of those intercoupled coils.
There's a balancing action which must be obtained.
But by all means, experiment, because you never know.
How many more questions are there?
All
We've got
right.
3 minutes. We're okay if there's a couple minutes over, but how many more questions?
Looks like
Bruce?
there's two, and then a couple of follow-ons for the Iron Core question.
Okay, real
So this
brief.
one, is there a threshold voltage where impulses start working related to displacement current? And are ground currents displacement currents?
Well, I mean, if you're going to use a disruptive power supply, so like an impulse supply, I mean, those are very, very nonlinear transients. So if you set your system up balanced, first of all, so you have if you're working with a TMT system and you set it up balanced, then you can start introducing, if you want to explore displacement effects, then you can then unbalance that system by providing impulses, and you can do that. You can do that with a powerful spark gap generator. You can do it with a thyrotron generator, for example. But it needs to be the intensity needs to be quite high. So, I mean, you can also do it, for example, just by charging up a big capacitor to a high tension, and then instantaneously discharging that into the system. That will also unbalance the system with a transient, and then you will start to see phenomena. So if you're going to work on impulse, with impulse systems, disruptive systems, then yes, you do need quite a lot of power behind that. I would say probably I would put at least 500 watts of power behind the transient impulse system. Would you, Akasis, what would you say?
I think you're okay with that.
Okay, all right.
And of course, for continuous wave operation where we're using radio frequency, then it seems as though that even at slightly lower powers, the magnification effect is quite substantial, but of course over long range, which is one of our tests, that's still up for grabs. We do not know for sure.
All right, so the last three are from Phil, so I'm going to read them all together. Causing a high potential between the copper coil and the iron coil that could that be exploited? And if it is pulsed at high frequency, and then last, the iron coil could act as an opposing coil for the earthing, especially if ran as bifilar, B-I-F-I-L-A-R, and in a pancake coil configuration may cause a negative voltage.
I think it's a very, what he's describing as questions are very relatively simple experiments that can be performed, but the complex interaction, there's so much going on, it would be hard to predict exactly what would happen. So by all means, a couple months, put it together and see what happens. One neat thing with the popping coils is that most of those systems and a lot of other credible devices tend to operate at relatively high voltage. So if you're applying impulses, you probably want to be 2 kilovolt or greater. But, and then the answer would be like a lecture.
And I think
Whatever the
to
result
answer
is.
the second question, if we were to pulse it with some type of definite high frequency, then we would see the effect of the skin effect taking over of the wire. Now, of course, because this is in a way a parametric variation of inductance with respect to just the actual geometry and composition of the, well, I guess we'll take in the iron wire, then of course, if we introduce high frequency into the equation, then we're going to have to consider the skin effect and just the overall loss. But of course, when we deal with the realm of high frequency, then that's when things become very interesting. But of course, it's just worthy of experiment to see and find
It's a
out
very
what
complicated
exactly is
question.
going to happen. But we cannot answer that off the bat.
Is that about it? Okay. If we can go down the line and share the websites and contact information, how people can.
Okay, so my YouTube is Parker Edmondson, and my Instagram is pman817.
If you want to see my work, you can go to am-innovations.com. I also have my videos on YouTube as well, but basically all of my work is written open source onto my website.
eMediaPress.com is the best place to go for any of the books, videos. EnergyScienceConference.com is a separate site that's just on the conference. The MWO is on vril.io, vril.io. Eventually, all the MWO stuff is going to be on eMediaPress.com. But eMediaPress.com is pretty much going to be the central hub for everything. And contact link at the very, very bottom is probably the best way to reach me. But try to look through the FAQ if it deals with download problems or whatever. If there's any kind of customer service, you can email help@emediapress.com. And if you need to reach me directly, you can fill out the contact form on the bottom.
hakasays.com/blog, also the main site. I post updates to the projects and things we're working on, usually every week or two, depending on what the day job does. I also, there's a BitChute channel if you look for that, and a lot of the experiments here, the behind the scenes, we have longer form videos and more descriptions of what we're actually doing.
Okay, I post my work on griffinggbrock.com. I also post relating videos on griffing.g.brock on YouTube. And my contact information, specifically email, is found on my website as well.
Okay, so Dr. Parkenstein, right? Doctor?
That was my old TikTok. So on YouTube, you can find me as Parker Edmondson, and on Instagram, pman817.
But there's a new TikTok
There's a new
channel.
TikTok. It's Dr. Parkenstein 2.
And hopefully the old one comes back, if possible. And Dr. Adrian Marsh, Haka Says, Griffin Brock, thank you, everybody. Yeah, give it up for these guys. So.